Hello Code Champs, I am your Fahad. Today we are discussing about operators. First, operators. Operators are nothing but the symbols which are used in C program to perform specific works. There are two types of operators are there: binary operators and unary operators. Before knowing these binary and unary operators, we have to know a small topic, which is operands. What is meant by operands? Let's see with one example. Here I am taking 5 plus 2 is equal to 7. Here I am using two values, 5 and 2, to get the output of 7. Here I am using two values, which is one is 5 and another one is 2. Here that means this is 5 is one of the operand and 2 is one of the operand. Here I am using two operands to perform a specific operation or specific work, which is specific. The specific work is addition. To perform addition, I am using two variables. Two variables are two values. That means two operands I am using. When we use two operands to perform one work, that means the operations are known as binary operations. And another one is when we use single operand, like 5. With using just single operand, by using single operand, if we perform specific works, then that means they are unary operators. Today we are discussing about what are binary operators. There are different types of binary operators in C program. Let's discuss one by one. Let's see: arithmetic operators, relational operators, logical operators, bitwise operators. First we all know that arithmetic operations are nothing but addition, subtraction, multiplication, division. This type of operations are known as arithmetic operation. This type of operations are known as arithmetic operations. To perform arithmetic operations, we are using these symbols: plus, minus, this symbol is known as asterisk, division. These symbols are we are using to perform this. For example, we use arithmetic operations in perform 5 plus 2. Here using I am plus to perform addition. I am using minus to perform subtraction, like that. Here relational operators are used to check the conditions in conditional statements like if statements, else statements, for loops, do while loops, while loops. In the places we use these relational operators. Like in next video we will discuss about for loops, if statements, conditional statements, like that. For in relational operators, let's see about this. Double equals to used to compare, used to check the if one double equals to 1. If this is our input, 1 double equals to 1 is it is comparison. In this example, 1 double equals to 1 equals to 1, it's true. Then the condition moves to further execution of code. If this 1 double equals to 2, then the conditions become false. These all are discussed in next video. And here are greater than, less than. Here also same like this. Conditions also conditions are checked. No, for example, 2 greater than 1. If it is true or not. If it becomes true, then it will goes to true condition. Otherwise it will goes to false condition. These are we discuss tomorrow. We discuss in next video. Sorry. And another logical operators also used in conditional statements. Conditional statements to check this and this is AND operator. This is AND operator. This is used to check the two conditions at a time, two or multiple conditions at a time. For example, A is equals to 2, B is equals to 3. If we give one condition in if statements like this, if B greater than A double and B greater than or equals to A. If we give conditions like this, first it will check this condition. If B greater than A, 3 greater than 2, it's true condition. Then In this the AND operator, both conditions both conditions must be true. If any one conditions became false, then it will move to false statements. Initially, you are yeah, I think you are feeling some confusion. In next videos, these all doubts will be clarified. We can see. Don't get panic. In next videos, in further videos, we'll discuss in detail about this all of it. Here, bitwise operator. Bitwise operators are used to perform works or operations on binary codes. Before using these bitwise operators, first we have to know about binary format of writing. Binary format of writing. For example, if we have to know about this 5's binary code, how can we know this 5's binary code? Before this, we have to know about one small formula is there. First take 1. 1 2s are 2, 2 2s are 4, 4 2s are 8, 8 2s are 16. Like this it goes. First, if we have to know to write the binary code of 5, write like this. Before writing this, we have to write this. By adding 4 and 1, we get the output as 5, because let's take here 1 and 1, and remaining all become zeros. 4 plus 1 become 5. That means its binary code is 0 1 0 1. This is the binary code of 5. By this formula, we can know about any binary format, any numbers binary code. For example, if we have to get about 14, how can we get the 14's binary code? Let's see. By adding 8 plus 4, how much? 12. 8 plus 4, 12. For 8 plus 4 plus 2, it becomes 14, right? See, that's why we are taking here 16. 16 is not used, that's why 0. Here 8 is using, that's why 1. 4 is using, that's why 1. 2 is using, that's why 1. And 1 is not using, that's why it becomes 0. Let's see. Here 8 plus. Here 4 plus. Here 2. What is the output? 14. That means the binary code of 14 is 1 1 1 0. We know that computer can understand only the binary format. If this C program is high level language, the compiler converts the high level language into binary format, which can be understood by the computer. It is difficult to write it is difficult to write the code in binary format, because computer can only understand two things, that is 1 and 0. That's why we have to convert the binary format. Let's see in another example. Don't forget this format. 1 2 4 8 16. This is used to know the binary format of any number. Let's see. And here AND operator. AND operator is used to, for example, these are 5 and 7. 5 and 7. First write the binary code of 5. What is the binary code of 5? Let's take that 1 2 4 8. 1 2s are 2, 2 2s are 4, 4 2s are 8, 8 2s are 16, like this. For 5, what is the binary code? Yeah, 1 is 1. We are using 1. See, 2 is not used. 4 is using, and another remaining all are zeros. The binary code is 0 1 0 1. This is binary code of 5. And what about 7? To get 7, we will take 4 2 1. That means 1 1 1. We are using 1. That's why I'll take 1. We are using 2, that's why I am taking 2. We are using 4, that's why I am taking 4. Because 4 to 1 I am using for by adding this 4 to 1 we get the sum 7, right? Sum 7. That means the binary code of 7 is 0 1 1 1. And operator, I think in plus 12 or intermediate second year, we in physics, I think logic gates are there. Logic gates topic is there. I learnt in second year only. Logic gates. In logic gates, what we know, or logic gate, and logic gate, not logic gate. Like this, we are learned. What about our adding a? This is addition operator. Addition. This is multiplication. This is converting. If it is true, then it will convert into false. Like that. Converting operator. It is converting operator. For here I am using bitwise and. That means we have to multiply 1 into 1, 1, 0 into 1, 0, 1 into 1, 1, 0 into 0, 0. That means what? We are getting this output. This output as result. For this binary code, what is the result? We have to check from this. This is first write what is this? 1 0 1 0. Here 1 means 1. Here this one is 1. Another 2 is not used. 4 is using. 4 is using. 1 plus 4. And 8 is not used. That means only 1 plus 4. The result is equal to 5. About OR. What is OR operator? Let's take 5 or 2. 5 or 2. It means first we have to write the binary code of 5. How can we write the binary code of 5? 1 to the 2, 2 to the 4, 4 to the 8, and this. Let's say to write 5. Which one we are using? 4 we are using. 1 we are using. 0 0. It means the binary code of 5 is 0 1 0 1. And what is the binary code of 2? 1. Only 2 I am using here. 1 0 0 0. What is the binary code? 0 0 1 0. Here OR is used to sum, addition. For example, I am telling that addition. 1 plus 0 1. 0 plus 1 1. 1 plus 0 1. 0 plus 0 0. Here I am getting 0 1 1 1. What is the result? Can you find from this? Let's see here. 1. Let's write here. 0 1 1 1. This means here I am using 1 and 2 and 4. What is the sum of 4 to 1? Is 7. The result is 7. By using OR operator for 5 and 2, we are getting 7. Do you understand it? Okay. Next we will see about left shift and right shift. If let for example 1 1 0 1 is equals to a equals to 2a. If a is equals to 0 1 1 0. If I write like this, a left shift 1, and that means we have to shift one value for left side. This gives the how in which side we have to here I am using only one shift. Left shift is 1 here. Let's this shift here. By what we get 1 1 0 0. This we get by shifting 1 by shifting one to right shift, this is right shift, shifting one to right side, what we get the output? 1, 2, 4, 8, 16. Here 0, 0, 1, 1. That means the result is equals to 3. Same like that. Same like that. Same like that. If A is equals to 1, 0, 1, 0. For example, A is equals to, the binary format is 1, 0, 1, 0. If I shift this A to left shift of 2, that means it shifts here 0, 0, 0, 0, 1, 0, 1, 0. 2 shifts. This is shifting to here. 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 Yes. Then also, then we get what's the value? 1, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0. What is the value for this? Here, if we write here 0, 0, 0, 1, 0. Now 16 to the 32. 32 to the 64. 0, 0, 0, 1, 0, 1, 0, 1, 0. Right? 1, 3 zeros, 3 zeros, 1. That means what is the result then? 32 plus 8. What is the value of 32 plus 8? 40. The result is 40. By shifting two binary codes by left side, then we get the result 40 for the operands, for the binary value 1, 0, 1, 0. Do you understand this? Here I am here is the example of AND operator and OR operator.